this problem even if you didn't have specific questions here. There were a lot of pieces to it. When we look at it, it's telling you to draw a sketch to support your answer. If I asked you to do a sketch on that, I'm not looking for necessarily a parent function and a transformation and 3 exact points on each, although you're welcome to do that. When I'm saying a sketch, I'm saying just a rough graph to kind of help you do that. So if we look at A, my function was the square root of x plus 4. So my graph, I know a square root kind of looks like this. What would the plus 4 do to my graph? So it would look like this. That's all I require for the sketch, although you can certainly do more. So then when it asks for the domain is the x. So it starts, you go from left to right, so that would be -4 to infinity, which was h. B, when I asked for the range of the square root of x plus 4, so the square root, that's the shape, what would the plus 4 do on that one? Up 4, because it's not under the radical. So if I take that graph up 4, range is talking about my y value. So as I go from the bottom to the top, the first point we hit is 4, and then everything after that. So 4 to infinity is b. So C, we know x squared is a parabola. What would the -16 do?
16.
So we have a parabola that's been shifted down 16. So there's my rough sketch. And then I want the domain, so domain is x. As you go from left to right, we are hitting everything. So that's -infinity to +infinity. D, that we have a parabola again. What's the transformation this time? So the range is the y, so you go from the bottom up. So the first point we hit is -1, and then it keeps going up forever, so -1 to infinity is g. E, what's a cube root look like? Yeah, kind of like your sideways chair. What's the, what's the -2 do? Because it's under the radical. So here is my rough sketch. Keep in mind it's a cube root, not a cube, so it looks like that. And domain, we are hitting everything. F. So we have a cube root again, but this time the +2 is on the end. So this takes our cube root graph up 2. And we want the range, which is your y. However, this does keep going down and that keeps going up. So we're still hitting everything. G, what's an absolute value look like? B. What does the +3 do? So the domain of that, if you go from left to right, we're hitting everything. H. What does that absolute value look like? This time I'm asking for the range. So range is your y, so starting at the bottom, my lowest point is -3, and then it keeps going up. So -3 to infinity, which is f. I, we have x squared, which is a parabola, -3. So down 3, domain, we're hitting everything. And J, what does that 2 do to my parabola? Right, it's going to make it get skinnier. I don't know what happened to my cursor. So it's just a skinnier looking parabola. But the range of that, the y values, still hitting everything. Oh, sorry, not range. I said range, but I was doing domain. Range, we're starting at 0 and hitting everything above that. So that was D. Questions on that one? Number 2 we didn't ask about, but it's a pretty quick one. What does a negative out in front do? The +4 and the +2. Okay. When you do that, which has to be the last piece that you do when graphing it? When you're doing transformations, you want to do the flipping first, save up and down for last. So really the order doesn't matter, except you want to make sure that you flip before you move up or down. Otherwise it does kind of change things. Okay. Number 3, this is something that we probably really need to review before this test. So we are talking about symmetry. And we have to check symmetry to the x-axis, y-axis, and origin. I would require some kind of work to explain this. So if you just tell me yes or no, you're not going to get credit on that. You need some kind of justification for why you're answering how you answer. So when I look at this, symmetry is saying, is this a graph where if I take that graph and flip it over the x-axis, it would overlap itself? And that happens when one x value gives you a positive and a negative y. So to check symmetry to the x-axis, algebraically, you could do it by replacing your y with a negative y. Is there anything I can do there that would get rid of that negative y and turn it back into the original equation? Right. I could, like if I divided by a negative, it would just move it to the other side. So I can move it away from the y, but it doesn't turn back into what I started with. So that means it is not symmetric to the y-axis. There is, or to the x-axis. There is nothing I can do to make those the same. If it's symmetric to the y-axis, that means if I flip my graph over the y-axis, it overlaps itself. So one y value corresponds to a positive and a negative x. So to check that, we change our x to a negative x. Okay, and negative squared is positive. That's the same as what I started with. So this is a yes, it is symmetric to the y-axis. Now symmetry, it's not guaranteed that it's symmetric to one thing and nothing else. We've seen problems where all of them were no's. We've seen problems where all of them were yeses. So you have to check everything. Origin is saying if you have a positive and negative x, or if you have 1 point, if you make your x and y negative, you also have that one. So to check origin, we do both. We do x with a negative x, y with a negative y. So if I do that, a negative squared is positive, but there's still nothing I can do to get rid of that negative on the y. So this is a no. So this graph is symmetric to the y-axis only. That's the algebraic method of doing it, but I didn't specify. I just said determine if it's symmetric. So another option would be to look at a graph. Okay, we know x squared is a parabola, plus 7. We move it up 7. The 3 is just going to make it skinnier, and you can even compare it on your calculator if you need to. if I look at this, is that graph symmetric to the x-axis? If I fold over the x-axis, does that overlap itself? No. If I fold over the y-axis, does it overlap itself? Yes. What about the origin? Remember, origin, you have to do both folds, the y and the x. Would it overlap? No. So if I don't specify, you could do either way. If you're doing the graph, make sure you at least sketch me a picture of your graph so I know what you're basing your answers off of. Then the algebraic method is just plugging in a negative for the opposite variables. Questions? Alright. So then we got into all of our graphs. So number 4 should have been your absolute value. So your V shifted left 1 and up 3. Is that one okay? Okay, let's look at number 5. Okay. So if I what does the greatest integer look like in general? Right, those steps. We have open and closed circles. Where do we begin on those? What do we have to look at? We usually just started with plugging in points and trying to get a complete step. The greatest integer is one where you typically can't just plug in whole numbers. You usually have to do some decimals as well to really get a true idea. So I usually start with 0. If I plug that in, 1/3 times 0 is 0. What is the greatest integer of 0? 0, and then the minus 1. That's a negative. Okay, if I put in 0.5, the greatest integer of 1/3 times 0.5. So 1/3 times 0.5, that's 1/6. What's the greatest integer of 1/6? 0, and then 0 minus 1? Negative 1. Right, if I put in 0.9, 1/3 times 0.9 would be 3/10. Greatest integer of that? 0 minus 1. Okay, so have I found my next step yet? No. So if I put in 0, we got negative 1. If I put in 0.5, 0.9, I'm still down here. A lot of times when we plugged in 1, we got it. So if I did 1/3 times 1, that's still 1/3 minus 1. Greatest integer of 1/3. And 0 minus 1 is negative 1. So we still haven't got it. Let's go ahead and plug in like a 2. So 1/3 times 2 greatest integer of 2/3 is 0 minus 1. So even at 2, I'm still down here. What should I plug in next? I put in 3. 1/3 times 3 is 1. Greatest integer of 1 minus 1. Okay, because this number inside my greatest integer was a perfect integer itself, that tells me it's the beginning or end of a step. So when I put in 3, we get 0. So that means we are on this step up until that point. So it gets an open circle. So what did the 1/3 do to my steps? They were 3 units long. So this one will go until here, and then you would jump up again. Or you can go the opposite direction. When we graph these, I always told you a minimum of 3 exact steps, and then if you just want to show me the pattern continued, you are welcome to do that. Questions there? Yes. Absolutely. Is 6 okay? We've had a little bit of trouble with the piecewise functions. Did you guys get 6? Okay. Let's look at 7. I also want to talk about number 8, just to practice at least one of these piecewise ones. So, parent function. Okay. So I expect the parent function with a minimum of 3 points. So since we're doing the square root, it would probably be helpful to do things we can do the square root of. So square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. So that's my parent function. Okay, transformations. What does the minus 2 do? What does this 3 do? Okay. So I told you if it helps on those, you could write out ordered pairs. These are the points we currently have. When you stretch, that's on the outside. So is it changing the x or the y? The y. So my x's stay the same here. But outside is y and it does what it says. So it's saying take it times 3. So 0 times 3 is 0. 1 times 3 is 3. 2 times 3 is 6. Bless you. So 0, 0 would stay right here, but then I have to move it right 2. 1, 1 would turn into 1, 3, but then right 2. 4, 2 would turn into 4, 6, and then go right 2. So we can see that our graph got moved over to the side and became really tall and skinny there. Is that okay? Okay. So this is a piecewise. We had a little bit of trouble with these on that quiz. Alright. So how do we graph a piecewise? how many of them will I need here? You have to have one for each piece. So for my first piece, what is the first number I have to plug in? Okay, and then what kinds of numbers do we have to do? So negative 4 plus 2, negative 5 plus 2, negative 6 plus 2. Okay, the negative 4 we did not have an equal to, so that will be open. That does not mean every point you plot here is open. It's just that first one. So negative 4, negative 2. Is an open circle. Negative 5, negative 3, negative 6, negative 4. So that piece looks like this. All right, middle one. We have to plug in both the negative 4 and the 2, and then we could do something in between. The 2 will be open because we didn't have the equal to, but the 4 will be closed. And we get the opposite of that. So the opposite of negative 4 is 4. Opposite of 0 is still 0. Opposite of 2 is negative 2. So negative 4, 4. Close, 0, 0. 2, negative 2 is open. So it looks like that. The last one, what do we have to plug in first here? And would it be open or closed? And then we need things greater. So 2 times 3 is 6, 3 times 3 is 9, 4 times 3 is 4. So 2, 6, 3, 9, 4, 12. Looks like that. Make sure you check at the end. These are supposed to be functions. It was f of x equals, so we know it's a function. So that means it has to pass the vertical line test. If it does not, then you have a mistake. Okay. Are we okay with number 9? You reflect it and move it down?
On 8 on the middle piece, do we have to have the same points?
No, the end points have to be there, but the other point could be whatever. Alright. 14. The domain of G divided by F. So G of X divided by F of X. G is 4x plus 4. F is 3x squared minus 2. So that's G divided by F. If we are asked to find the domain in a fraction, what do we know?
8 cannot be 0.
What can't be 0?
Is the domain.
So we can add the 2 over. Divide by 3. How do you get rid of a square? When you add that, what do you put with it? Okay. This is the same thing as saying the square root of 2 divided by the square root of 3. We don't leave radicals on the bottom, so if you multiply by radical 3 on top and bottom, you get the x cannot be plus or minus radical 6 over 2. Since it's more than one thing x can't be, I've been letting you leave it like that. If you chose to write it as an interval, it would be everything smaller than negative radical 6 over 3. Union everything between them. Union everything bigger. Is that okay? We didn't ask about 16, but it might be helpful. You wanna look at that one? So 16 was asking for the difference quotient. When I had you do these, I kind of broke it into a 3-step process. A, we found f of x plus h. B, we found f of x plus h minus f of x. C was the whole thing. So f of x plus h says you go to your function, you replace your x with an x plus h. How do I do x plus h squared? So we can distribute our 3 and we just get 3x squared plus 6xh plus 3h squared minus 2. That's okay. You need to take your test?
I'm I got a simple case out of that.
Alright. B, f of x plus h, so that's the answer we just got. Minus f of x, that's the original, which was 3x squared minus 2. So we have to distribute that negative. So 3x squared and negative 3x squared cancel, 2 and negative 2 cancel. And we get 6xh plus 3h squared. C, f of x plus h minus f of x. All over h. So if we divide those by h, we get 6x plus 3h. We've taken h out of each. So that is our final answer. Alright, 17. Let's look at that one. So f of x is negative 2 over x minus 5. G of x is the square root of x plus 6. So part A, domain of f. This has a fraction. We know in a fraction the bottom can't be 0. So x cannot be 5. So our domain is negative infinity to 5. And then 5 to infinity. B, we're doing the domain of G. G has a square root. If you have a square root, what has to be true? The thing under the radical is greater than or equal to 0, which means x is greater than or equal to negative 6. So if we write that as bracket, negative 6 to infinity. C and D were okay on those. 18, you should have gotten negative 12. You guys didn't ask about 19, but I'm going over it anyway. I want G composed with F and its domain. So you start on the inside. F is 3 over x. If you put that into G, that's 5 over 3 over x minus 1. On the quiz, we had a few mistakes with this. What do you have to do right now? Okay. You take x times everything. So 5 times x is 5x. 3 divided by x times x is 3. minus 1 times x is x. A lot of people miss that second x there. So that's my composition. For the domain, where do we have to look?
Wasn't the answer G, the 3
If I look right here, I know x can't be 0. Here, 3 minus x can't be 0, which means x can't be 3. So my final domain, you can either tell me x cannot be 0 or 3, or you can write the interval. Negative infinity to 0, union 0 to 3, union 3 to infinity. Those okay? Was that one okay? Um, 21, you just draw your graph and look at the domain. 22, this was another even and odd question. So my function even is the same thing as symmetric to the y-axis. Odd is the same thing as symmetric to the origin. So you have some options for how to do this. You could, f of x is the same thing as what variable? Y. So you could write that as y equals, and then do it just how we did problem number 2. No, not 2. 3. When we checked for symmetry. Plug in negatives to the opposite variables, see if it works. With functions, it was a little bit easier. What we could do is just plug in a negative for the x. If you take a negative to the 5th power, is it positive or negative? Negative. If you take a negative cubed, it is negative. So a negative 2 times a negative x cubed. So we get negative x to the 5th plus 2x cubed. Is that what we started with? No. Is it the exact opposite, what we started with? Yes. So that means odd. It's essentially saying if x is negative, then y is negative. So the other option here, other than just looking at symmetry, even, if you put in a negative x, you get the same answers when you put in a positive x. Odd, if you put in a negative x, you get the opposite of when you put in a positive x.
Can you go over the continuous one?
Okay, so first, you have to get a graph. So we start by plugging in 4. Since there's no equal to, that would be open. So 2 times 4 minus 3, so 8 minus 3 is 5. You put in a 5, 10 minus 3 is 7. If you put in a 6, 12 minus 3 is 9. So 4, 5 is open. Oh, yeah, I went the wrong direction, didn't I? And I would have caught that in a second because it wouldn't have been a function when I graphed it. And that's why I did that, just to make a point. See?
I was thinking that I had. I was like,
No.
It's maybe I don't.
We're supposed to be doing less than, so how about a 3 and a 2? So 6 minus 3. Yeah,
I
see?
was
Just
confused.
jumped the gun there. I was getting to it.
I was showing you I was paying attention.
I appreciate that. Okay, so that is a slightly crooked line, but it'll work. The second one, we start with the 4, but it would be closed because add an equal to, and then you do things larger than 4. So if you put in 4, you get 2, 5 gives us 1, 6 gives us 0. So 4, 2 is closed, 5, 1, 6, 0. Notice how this is a function, passes a vertical line test. Okay, as we go from left to right, what's that first piece doing? Increasing. It's coming from negative infinity and stops when we get to 4. You use the x values here. The only time you're giving me intervals with y values is if we are talking about what? Range. Range is the only time we can use y's. Then the next piece, what's it doing? Decreasing, starting at 4 and going to infinity. Is this graph ever constant? There's no flat lines. Then continuous. Okay, is the entire graph continuous? No. So continuous is like saying, where can you graph this without picking up your pencil? So I can start from negative infinity. I would have to stop when I got to 4 because it's open. That would be a union or a parenthesis. Union, then the next piece it starts at 4 and keeps going forever.
So just because one of these is closed and still do this.
Yes. And you can put a bracket on this one because it has the closed. But this one had to have parentheses because it came to an open circle. So continuous is like saying where can you graph it without picking up your pencil. Other questions there? So the other thing I wanted to talk about, when I asked for the f of 4, f of negative 6, and f of 5, I would probably, might be safer to use your equation rather than your graph in case your graph isn't perfect. So when it says 4, that means you have to go to the piece where it's equal to 4. So the opposite of 4 plus 6 is 2. If I say negative 6 is less than 4. So you have to do 2 times negative 6 minus 3, or negative 15. When I say 5, which piece are you plugging that into? Right, 5 is greater than 4. And we get 1. So just make sure you're using the right piece there. The last ones you didn't ask, let's check our answer. 23, you should get negative 3 and negative 1. 24, negative 1 and negative 1/2. 25, negative infinity to 5/3. Union 3 to infinity. The 5/3 and the 3 should have brackets. 26, negative 7/5 to 3/5, both with parentheses. 27 is 1 to 7, both with parentheses. And 28 is no solution.
And 26 and 27 do one big.
Yes, because it was a less than, so an and.
How do you work 27 and 24 and solutions?
You can do solution set, or if you just say x equals, that's fine as well. Anything else you want me to go over? So So test is tomorrow.